We are videoing this class on U-Substitution. Okay, now if you look at the board, we have a quiz tomorrow. Look, I even told, well, it got erased. Who erased it? Okay, this is what's on tomorrow's quiz. You're going to have two differential equations to solve. You have to draw one slope field, and there will be 4 U-substitution problems. And here's a sample of the differential equation, like dy dx. Here, it's got it right here. Who erased it? With the initial condition y of 0 equal 1 or something like that. Easy, right?
Wait, what's SF? Sorry.
Slope field.
Oh, so you just draw.
So I'm going to give you like 4, 5, or 6 points. Draw a slope field at the indicated points. And then 4 U-substitution problems, but they're going to be basic U-substitution. Nothing difficult. Like some of the problems on the homework are kind of difficult, yeah?
Yeah.
But then some of them weren't.
Yes. But then some of them were.
Yeah.
Back to that.
So I'm going to tell you right now, if the reason, and we're going to plan B. We're going to, instead of doing 2 nights of this homework, we're going 3 nights of this homework. You guys have no idea how important this is. If you cannot do U-substitution, I pretty much guarantee you're going to fail this quarter. Because everything depends on U-substitution. This is the most important technique we have. And then, since I'm giving you an extra night, 7.2 is going to be due. In fact, 7.1 as well. Yeah. No, just 7.2 video. 7.2 is due on Monday. Beginning of the period Monday, you're handing that in 40 points. No, 20 points. Let me say 40. So it's going to be worth double points. That's because of how the importance of it. All right. Woo! Okay, so hopefully you guys did a bunch last night, because if not, good luck this quarter. Okay, I'll tell you right now, number 21 is like at a different level. We'll come back to that one at the very end. Okay, so say, look, 21 on hold. Okay, 30. Yay! You guys are better than the other class. No, you're not.
That's why you say you don't have to do YouTube.
Yeah. Now, okay, let me tell you what you should be thinking when you see an integral. Does everybody have that list memorized yet?
The integral?
The integral list. Of course not. We need a speed quiz on that, yeah?
No.
Yeah. No.
Yeah.
Well, I'll tell you what, as you do your homework and you look at the list, then you start memorizing it.
Yeah.
Okay, anyway, this is what you should be thinking when you see a problem. Is that on the list? And then if it's not on the list, can I make a U-substitution that puts it on the list? That's what you should be thinking right now. Now, is this on the list? Yes, it is. But it's not recognizable yet. Now, isn't sine x to the negative 2 the same thing as 1 over sine squared x? Here, let me write it then. And what is 1 over sine squared x? Cosecant squared x. Is that on our list? You bet your bippy it is. Throw the constant on the side. What's the antiderivative of cosecant squared? Negative cotangent x plus c. So there is no U-substitution for this problem. It's on the list, that's why. You only make a U-substitution if it's not on the list. In fact, there was another problem just like this on last night's homework. Do you guys remember what number it is? It was 36. Is that on? That's the next problem. Maybe that's why you guys are having a hard time. Now, anyway, if you tried to make a U-substitution for this problem, what would you let u equal to? U equals sine 3x? I mean, if you were to try a U-substitution, that's what you would do, right? But if you let u equal to sine 3x, what's the derivative of that? Cosine 3x times 3 dx. Do I see a cosine 3x in the problem? No, because remember, whenever you let u equal to, the derivative got to be in there as well, and it's not. So that's why you can't even do a U-substitution in this problem. That's why you change that to cosecant squared 3x. And is that on our list?
Yes.
Yeah, it's negative cotangent 3x plus c, but since the derivative of the box is 3, how do we adjust it? You put a 1/3 in the front. Finished. Yeah.
Can you not do the U?
You let u equal 3x.
Yeah.
Yeah, but I told you guys we're Ilani. When the derivative of the box is a constant, we adjust for it. We don't need U-substitution. Like here, if you have integral of e to the 5x dx, do I need to go u equal 5x, or can I just go e to the 5x plus c, but the derivative of the box is 5, so you put a 1/5 in the front? We've been doing that for 2 weeks already. Oh.
Yeah.
If the derivative of the box is a constant, we just adjust for it. So, in your homework then, there were some problems where you didn't need, like, for example, number 17. Number 17, number 19, you just look at those and write down the answer,
Oh.
right?
Yeah.
Okay, here, let me demonstrate. Some of you, what you talking about, Willis? 17, look, sine 3x dx. What's the antiderivative of sine? Negative cosine. But since the derivative of the box is 3, we put a 1/3 and then put plus c. We don't need to make no stinking U-substitution, because the derivative of the box is a constant. We know how to adjust for that. Okay, now we're moving on. Are you sure? Okay, I'm telling you right now, everybody in this room can do problem 29. I'm gonna walk around with my grade book now then.
No.
Yeah.
What? I didn't even do it.
Yeah,
Then how come it's not on the board?
I did.
Because I didn't do it.
Yo, well, we know that already. 29. Well, it's not on the board, must be like, okay, let me ask some people. Fleischer?
Huh?
You did 29? This is gonna weigh heavily. No, I'm just gonna make a statement here. Some of you are in the running for top AB calculus student.
What?
You know, there's an award at the end of the year. Some people's stock has just dropped.
No.
Who was it last year?
Wasn't my student.
Oh, it was Taylor was doing
Wait, I didn't even
No,
know.
see, I have a certain standard for top student. So if I don't think any of my students, because some teachers say, oh, whatever their top student is, they submit it no matter what. But I have a standard. If I don't think they're at that standard, I'm not going to even submit their name. But this year, I actually think there's several people.
Is it me?
Unless,
Wayne.
it.
okay, well, first of all, you got to have a high grade. It's like 97, six,
It's not me.
like 95 or higher.
Wow.
Come on, you should know what your grades are by now. And then you got to look at the intangibles, like, did they complete their homework when they're supposed to? Okay, anyway,
That's definitely
let's just
not
do this
me.
problem. Okay, enough ranting and raving. Okay, now, huh?
Did you do the other class chapter?
No, because we ran out of time, so you're not going to get it back today either. Too bad, that's the way it is. But since I'm giving you an extra day to do the homework, we're going to spend 3 nights on this homework for sure tomorrow.
Okay.
Okay.
You just suffer and wait. Okay, now what are we doing? Oh yeah, we're doing this problem. Okay, so first step, the first thing you ask yourself, is this on our list?
No.
Okay, Fleischer, time to redeem yourself. Is this on the list? Yes, it is! This is on the list. Maybe it's time some of you actually download the list of derivatives and integrals and put it on your front page or whatever you call it. What do you call it, home screen? Yes, okay, let me show you. Is this integral on the list? The integral of tangent u du is equal to negative natural log absolute value of cosine u plus c. Is that on the list? Yeah, okay, Shin. Shin knows.
Wait, what read?
So what? Okay, Shin, Fleischer. Okay, so the rest of us don't even know what the list is. Okay, so how do you do this problem? Okay, how do you do this problem if you don't know what's on the list? Mr. Park, how do I make a U-substitution? If I let u equal tangent, then the du will be secant squared. I don't see no stinking secant squared. Now, if you read your book, the book tells you how to do it. change tangent to
Sine.
sine over cosine.
Problem.
Oh, oh. Now you can make a U substitution. U equals what? Sine or cosine? You know what the other class told me? It doesn't matter. Because if you let U equal sine, they said there's cosine right there, but there's your downfall. This is not cosine, it's 1 over cosine. It's in the denominator. So you should make U equal to cosine. Yes, that's what you should do. Because, okay, you guys are gonna have to do something. Ichimura, redeem yourself. What's du?
Redeem myself. I didn't do anything wrong today. Oh.
You didn't do the homework.
Oh, that's true. Negative sign of the thing. dx.
But I left a space.
Oh, 1/4.
No! See,
I don't know.
that's, we're taking the derivative. The derivative of cosine box is negative sine box times the derivative of the box.
1/4.
See, if you put a 1/4 there, you're confusing it with the antiderivative. When you do U substitution, you have to take the derivative to go from here to here. And then when you get to the integral, then you do antiderivative. You gotta be able to do both. Okay, so this becomes, what's that? So it's U. And then what is sine of that dx right there? What is, oh, what's that right there? du over -4. So du over -4, but we throw the constant on the outside like that. And is that on my list? Yes, that's negative. Oh, I like this phrase mix. Natural log, absolute value of u plus c, resubstitute back in, and so your answer going to be -1/4 natural log absolute value of the u, which was this, plus c. Now, by the time we get to the test, okay, every single year, this is what happens. Points get taken off, and by the time you're done for. Okay, you know when you make u and then the du, a lot of students don't write the dx. That's a -1 every infraction. You don't put the plus c, that's another -1. What if I put 1/4 there instead of a 4? That's a -2 infraction. We call that derivative error. Okay? And then of course, if you don't resubstitute back in, then that's going to be another -1. So you pretty much lose all the points just on dumb stuff. Okay, now, so do you guys see this technique that you have to use to integrate tangent? You got to change it to sine over cosine, and then you got to make U substitution. But I'm telling you right now, the integral of tangent and cotangent come up so often in calculus, we don't want to reinvent the wheel every time. So that's why I put it on my list. Now, BC calculus students, they don't have it on their list because they just do this every time. But it is on our list. So for those of you who don't know this, we got this, and the integral of cotangent u du is natural log absolute value of sine u plus c. Just look at your list, it's right there. So, if you knew this was on the list, you could just look at this problem and write down the answer. Look, the integral of tangent u, that's on the list. That's going to be negative natural log absolute value of cosine box plus c. But since the derivative of the box is 4, how do I adjust for it? You put a 1/4, and then look, that's the same answer. Except this problem took 5 minutes, this problem took 5 seconds. You need to know what's on the list. I think we need a speed quiz next week.
Oh no.
Yes, we do. Because if you're gonna fail. This, what are we doing third quarter? Integrals, integrals, integrals. That's what we're doing. That's all we're doing. And then applications of integral. But before we can do applications of integrals, you guys gotta actually be able to compute integrals. This is the struggle that we're having right now. It's a big struggle. Okay, let's move on. 36. Did we do 36 already?
Yeah.
You sure people don't want to? How come the other class asked so many questions on them? But not this class. Oh, 37! Oh, see, I got so worked up in that class. I said there are 2 methods of doing this problem, and I forgot to show them the other method. Okay, now notice that I wrote x's instead of t's. When on my quizzes, I'm just gonna put x's, I'm not gonna put other variables. Okay, so this is what you should be thinking. Is this on our list?
Yes.
No.
Ah, Ichimura. It is. It is on our list.
Is it?
How is this on our list?
Tangent times secant.
See, Ichimura nailed it. He redeemed himself. So time Ichimura. See, so his stock was already down here. It can't reach that low, and then it just came up a little bit. Does everybody see? This is on the list. Isn't this the same thing as secant
Yeah.
tangent? Stare at that for a while. 1 over cosine is the secant, and sine over cosine is the tangent. Hey, that's on the list. What's the integral of secant u tangent u?
Secant.
Now, if you don't know what's on the list, then it's over. Secant u. But since the derivative of the box is 2, we have to adjust for it by putting a 1/2 there plus c finished. We can do that problem in 5 seconds if you recognize that. Now, the rest of us. Hey, Festivus for the rest of us. You guys know what that means? You guys never heard of Festivus?
I've heard of it.
Oh, it's like
It's like Seinfeld. You guys watch Seinfeld?
Christmas.
Oh, that thing?
Yeah, that's because, do you guys even know the characters on Seinfeld?
Yes.
Yeah.
George Costanza.
Yes.
His father didn't like the concept of Christmas, so he invented a new holiday, his own holiday. Festivus for the rest of us. So instead of a Christmas tree, they have like a Christmas pole. And then you have like these things like, what did they do? The airing of grievances.
Exactly.
And then the feats of strength,
Yeah.
where you have to wrestle him. Anyway, let's get on with this problem. So, for those of you who didn't recognize this, then your only other option is to do U-substitution. U equals, okay, you have 2 choices. Should I let U equal sine 2x plus 1 or cosine 2x plus 1? Okay, good. Cosine 2x plus 1. What's du? Okay, let me call on somebody here. Rosadilio.
Negative sine times 2. Let's see. No. What am I missing?
dx. dx. Taking derivative now. Remember, this is actually du over dx. We're multiplying the dx in this. Okay, I tell you what, because I know every single year, students don't put the plus c, they don't put the dx. You write this on your paper on the AP exam, that's automatic -1. Because these are not equal. This is equal to that. So if you multiply both sides by dx, you gotta have that, otherwise they're not equal.
So if you don't show that.
So if you don't put the dx, it's like saying 1 equals 2. That's wrong.
What if you just don't show that work at all? The du.
Then you go get 2 points off.
Uh,
What are you guys trying to do? Already my health is deteriorating. I don't know what you guys are gonna do to me by the end of. You know how I lie in bed at night just thinking about all the heartache and headaches I'm gonna get in the 4th quarter trying to train you for the AP exams.
We'll just bring you
I
food.
shudder. I
Just
shudder.
have food every day.
That's not gonna help.
Like assign someone to bring
Look,
food every
I
day.
think by the end of the 4th quarter, my hair gonna be all white. That's my prediction.
It's like halfway.
Not gonna have any black. Okay, what do I substitute for that?
It's okay, my dad has a bald spot.
Right on. U squared. And then what do I substitute for this? Which is right there. Du over
Two.
-2. Is that on our list?
Yep.
Yes. So -1/2. Now this is the same. Now, you know what period 3 had the gall to say when we did this problem? They go, oh, natural log, absolute value of u squared plus c. Now some of you going, that's right, isn't it? No! If it's 1 over u to the first, then you do that. This is u to the second. So this is like u to the -2.
Okay.
You make the power 1 bigger, put the reciprocal in the front plus c, resubstitute back in, so your final answer is going to be 1/2. What is u? Where's u over there? Cosine of 2x plus 1 to the negative 1 plus c. Mr. Park, I thought this was the answer. It's the same thing, Charlie. Who's Charlie? So, when you see a problem like this, when you want to do U-substitution, and you get the same thing, or would you rather go, oh, it's on the list, I just write the answer down. Okay, I'll let you answer that by yourself. This is slowly killing me. Okay, next. Are we really going all the way to 46?
Yep.
Are we good? No. You gotta give me at least 10 minutes for today's
Okay,
lecture.
skip to 40.
Oh, no, I thought we finished 11 and 1, 11, 13. Okay, we can keep going.
Skip to 40? Okay.
Skip to 40? How come only Fukuda got questions?
No, 42.
Okay, let's do 40 first. Wait. I think we should do 39. Because, okay, I'll tell you right
Is
now.
that not just Ellen?
Yeah,
Okay, I guess back.
okay, let's do 39. This is the level of tomorrow's quiz. Tomorrow's U-substitution problems are based, this is considered basic. Basic. Okay? This is the kind of level that you have to do. Okay? What should I let u equal to? You have two choices. Should I let u equal to x or ln x? Okay, now I already told you, you never let u equal to x because you're going to end up with the same darn integral you started with, except with u's instead of x. So anyway, like I told you yesterday, when you start getting good at this, when you see an x in the denominator, that's kind of like, oh, I should let u equal ln x already. Why? Because the derivative of ln x is 1 over x. That's how the x comes out in the denominator. But you're not going to understand that until you do a couple dozen problems. Okay, so this integral becomes, what's that right there? It rhymes with mu. U. And then what is dx over x, which is right there? Du. And is that what it is? Yes, that's natural log absolute value of u plus c. Resubstitute back in, and I am money. What happens if I forget the absolute value? -1. What happens if I forget the plus c? Another -1. Imagine doing that on every single problem.
Can you get negative?
No.
Oh.
So on the test, probably each one will be 5 points. So you can still salvage 3 out of 5. 60, good score.
No. Not really.
40, are we doing 40?
Yeah.
Okay, good. This is a basic problem for tomorrow. So for those of you who haven't done the homework, which might be several of you.
Probably all of us.
No, it's not all. I bet you some of you did the
Who
homework.
finished the homework?
No, a lot of people didn't finish.
Oh.
You actually finished it?
Are you kidding?
Of course not. I did the first one, I was surprised.
I almost.
But some of you did some problems, right? Like Fukuda and the White
I did
House.
some problems.
I did some.
Yeah, because one means some in mathematics,
I
right?
did up to 14.
What is?
What should I let u equal to? You got two choices, tangent or secant.
Secant.
Tangent.
Okay, let's think about it. Let's do the wrong one first. If I let u equal to secant, the derivative is going to be secant x, tangent x, right?
Yeah.
Do I see tangent x, secant x?
Yeah?
That's tangent
Oh.
squared. That's tangent squared. So EA, 9, yeah. And if I knew how to say no in Korean, I would say that too. Of course, I'm 100% Korean. I don't know the difference between yes and no. Yes is
I
nay,
know, oh my.
and no is somebody?
아니요.
You sure?
안녕하세요.
I'm just making that up. That sounds racist.
No.
U equals tangent.
My mother is fresh off the boat. And she
Oh, and she says that a lot to you, right?
she taught.
안녕.
At,
So what is it?
아니요.
안녕. So nay is yes.
안녕.
안녕, no. I should be able to
means I
remember
can't.
that.
아니요 means no.
No, I know.
No, I can't. No.
So when you start asking a question, just go 안녕.
Actually, she doesn't used to do that.
Okay,
Okay, let's just continue. What's the derivative of tangent? Secant squared. Hey, you somebody. See, that's why you let u equal to 10. So this becomes whoop
U squared.
and hey baby
U.
du. Hey, that's on the list. 1/3 u cubed plus c resubstitute back in. What happens if you don't resubstitute in like several people last year? -1, -1. But they all add up. And if you keep doing that on every single problem, pain, that's what happens. All right, let's keep moving on. So does everybody understand the level of the quiz tomorrow?
Yeah.
However, when I give you the quiz on Monday, the level will be kicked up
Just give
enough.
me a
Yeah, it could be like number 21, which I'm going to show you after I do a few more problems. Okay, let's do one more. What about 45 or 46?
Yeah, I
Yeah,
said that.
Okay, 45 and 46 are the same problem, I'll do 45. I do 46 at the end.
Understand it.
Maybe I should do 46 because 45 is odd.
Yes.
If you say so, Mr. Park. Okay, I'm gonna put this book down already. It's making my back even worse. Okay, is this on the list?
Yeah. No.
Yes, it is, it's on the list. So, after today, we're just gonna write it down, but see, some of you don't know that, so, if you don't know the list, this is what you gotta do. Now, the book gave you a hint. The book said, if you wanna make a U-substitution, you're gonna have to multiply top and bottom by something, and you know what that something is? Cosecant x plus cotangent
I was
x.
so confused.
No, it's not. Now, is that legal? Can I multiply top and bottom by the same thing? Yes, okay. So now you can make a U substitution. U equals cosecant x plus cotangent x, which is the whole denominator. Hey, Mr. Park, I let U equal to the whole denominator lots of times on last night's homework.
Yes.
For those of you who actually did the problem. Yeah, that happens quite often, people. Okay, du equals, what, okay, and you know, I gotta call Lamb, redeem yourself.
It equals to 10. No, that's ridiculous.
Yeah, that is
Cosecant x tangent x. No.
Año.
Año. Plus.
No. Año.
Divided by cotangent.
Año.
Plus.
No.
Minus.
You put it not. Minus.
Minus.
Oh, cosecant squared x.
Oh,
It's
you
cosecant
change your
squared
appearance.
It's cosecant squared x.
Oh, plus c.
No! dx!
Oh,
One.
going so well. You actually almost did
Okay, I'll tell you right now. If you cannot even compute a derivative, how can you even do U substitution? Yeah, you don't, that's right, you just skipped it and
If we can't do derivatives, how are we still here in that?
Yeah, I don't understand. Now, do you see? Okay, wait, Mr. Park, you said, if I let U equal to this, the derivative gotta be in that integral. And is it?
Yes.
Look, what happens if you distribute this cosecant to the top?
Oh!
You get cosecant squared x plus cosecant x cotangent x.
That's next.
Isn't that what that is, except with the negative sign factored out? Look at it. Okay, Harold, let me write it out there so that some of you go, what? What you talking about, Willis? Right there. Look. So this integral becomes, what do I substitute for that?
U.
No, yeah, on the bottom row. And then what do I substitute for this dx right there, which is this stuff right there?
Negative.
Negative du, and hey, that's on our list. That's negative natural log absolute value of u plus c. Resubstitute back in, so your final answer will be negative natural log absolute value of cosecant x plus cotangent x plus c. Yes.
How would we know to use cosecant x plus cotangent?
Yeah, okay, so that's my next question. How many of you can remember this technique?
How do you even know like that?
Because they gave you the hint in the
No,
book.
but what? Like if you had, they didn't give you the hint again.
Then you gotta figure it out. So that is why, and I'm telling you right now, the integral of secant and cosecant comes up quite often. That's why it's on my list. So for those of you who still don't know the list,
I have
let me
it.
write down two more on the list that you should know.
Here.
Integral of secant u du is equal to natural log absolute value of secant u plus tangent u plus c. And then the integral of cosecant u du is negative natural log absolute value of cosecant u plus cotangent u plus c. These need to be committed to memory. Or it's up to you. If you don't want to memorize it, then you reinvent the wheel. Here, good luck memorizing what to multiply top and bottom by. Miyashiro.
So if we're doing the homework and we see that it's on the list, we don't have to show.
Yes,
it.
exactly.
We just-
That's what I want you to do.
Oh, okay.
So when you see this problem, this is what you're supposed to do. Hey, this is on the list. Boom, finish. That's what I want you to do.
Good.
Yes, AP exam. Although I haven't seen this problem on the AP exam. Okay, let's go back to 21. Okay, what was 21 again? Integral
dx
What did that?
over x
squared
squared.
plus 9. Okay, now, I think the book gave you a hint, but there's no hints tomorrow. Anyway, this is a different level. This is a harder. The ones I'm going to give you tomorrow, all you have to be is like, you just have to be out of the womb, you know, you know, just like crawling even, or even like toddling, okay? Something like this, you gotta actually be like walking on twos like this. You know what I'm talking about? Your legs gotta be sturdy. So this is, I'll tell you what, this problem I'm gonna put on Monday's quiz. Except I'll change that number to a 16 or a 25 or a 4. But it's the same problem. Now let me ask you this. If this number were a 1, could you do this problem?
Yes.
Yeah, hey, that's on the list. Tan inverse x plus c, right? But it's not a 1, Mr. Park. What do? You make it a 1. How can you turn a 9 into a 1, Mr. Park? By factoring out the 9. Okay, what happens when I factor out the 9? You get what? X squared over 9 plus 1. See, now you got the 1. Yeah, but then that made this one ugly, but that's no problem. You can U-substitute that. Look, watch. What do I let u equal to so that I can get u squared right there?
X over 3.
X over 3. That was the hint they gave you.
Yeah.
But you're not going to get that hint anymore, so it doesn't matter. What is du then? 1/3 dx. So this integral becomes, okay, that 9 doesn't change, that 9 stays there. What do I substitute for that? U squared plus 1. What do I substitute for dx? Move this on this side. What? 3 du. But the 3 over 9 can be thrown on the outside. All constants can be thrown on the outside like an unwanted pet. And is that on our list?
Yeah.
Yeah. So that's 1/3 tan inverse u plus c. Resubstitute back in. Final answer, 1/3 tan inverse x over 3 plus c. Boom! Can you see that problem takes more thinking? Yeah, that's why that one's not on tomorrow's quiz. Tomorrow's quiz, look at that, I erased the grid. The basic. You just do one U-substitution, which is kind of obvious to see, boom, it's right there. All right, okay, today's lesson. Okay, we've got 8 minutes
You
left.
have a lesson?
Oh boy.
It's the same thing, it's still U-substitution, except, okay, this is last night's homework. Okay, let me give you one. Integral. Okay, this is the level that you would be expected to do tomorrow. Square root x cubed plus 1 x squared dx. Okay, this is the level of tomorrow's quiz. What would you let u equal to? X cubed plus 1, right?
Yep.
Yes.
Okay, but tonight's homework, the only difference is, now, there's limits on it. So, what difference, what do you do when there's limits on the integral? Now, this is a definite integral. How do you compute this? Do we do the same thing? Yes, you do the same thing, except there's a little thing you do in between. Okay, so we start the same way. The first thing you ask yourself, is it on the list? No, so I'm going to do a U-substitution. What should I let u equal to? You just told me x cubed plus 1. du is equal to, okay, let me call on somebody. Jenkins.
3x squared dx.
Thank you for not saying plus c like the other two called.
Okay.
Is this going to work?
Yes.
Yeah, because look, x squared dx. Look, x squared dx. It's
Sure.
going to work. Yeah, but the constant parts don't matter because you're throwing the constants on the side. Okay, so this integral becomes, what's that?
U.
Radical u. And then what is this? X squared dx.
1, 2,
du over 3, but we throw the constant on the outside. And what are my limits?
0, 2.
No! If anybody does this, -2, if not -3.
What?
Because you see these limits here? These are the limits for when the variable is x. It goes from x equals 0 to x equals 2. Once you make a substitution, you have a different variable. The limits are no longer 0 and 2.
So you didn't need to put
Is it
any
1?
No, but there are numbers now. Now it's a definite. See, last night's homework, they were all indefinite integrals. Tonight's homework, definite integrals. You have limits. So, Mr. Parkton, how do I figure out what these new limits are?
Is it 1?
You go back to your original substitution. You look at this.
Plug it in.
It's simple. Look, if x is 0, if I plug in 0 for x there, what is u? 1. So that's 1. When x is 2, what happens when I plug in 2 here? You get 9. Those are your new limits. So if your integral changes because you made a substitution, the limits are going to change as well. You guys understand? That's pretty easy to understand, right? Now can you compute this integral? Yeah, you use the fundamental theorem of calculus part 2. So throw the 1/3 on the side like an unwanted pet. Can we do this integral? Yes, it's on the list, people. I'll give you a hint. This is the same thing as u to the negative half. Make the power 1 bigger. Put the reciprocal in the front, and then we go from 1 to 9. How come I'm not writing the plus c again?
That's ridiculous.
Because they cancel out. Whenever you do definite integrals, the plus c's cancel out. Do I have to show you again? No. Okay, now, I don't know if you guys are doing this, but watch what I do to save time. I factor out the constants. Why am I whispering? You factor out the constant of 2/3. That way, all you have to do now, plug in the top number. Plug in the bottom number. Subtract 4/3. See, because if you don't factor out the constants, then you gotta go like this. Okay, 9 to the 1/2 is 3. 3 times 6 is... That's not 2. I'm giving you. 3 times 2 is 6. 6 divided by 3 is 2. Then you gotta write that down, but then no need to do that anymore. You just factor out the constant. It's a lot easier. But it's up to you. It's all gonna come out. Doesn't matter if you eat strawberry oatmeal or blueberry oatmeal. It's just gonna come out, right? You should get that at the end, right? Okay, so tonight you do some more problems, and then your what do I call your U-Substitution, what am I talking about? Ability will ameliorate. Is that a word you're supposed to know?
Yes.
I don't know what it means though.
Improve, to augment.
It's the same word.
Augment! To make bigger.
I know what that means.
Okay, whatever. Okay, the bell's gonna ring in 2 minutes. Or is it 3 minutes? 3 minutes. You know what would be a shame if I didn't turn this camera on? Oh, but I did. Count your lucky stars, Stark.